Hi all. The today's topic is transistor. We know the transistor is the backbone of most of the modern electronic devices. From the transistor only we are getting the all the IC chips. Transistor is a basic one for the IC chips and all electronics. All the electronics components are formed one and only by the transistors. So first I want to introduce myself. Myself Dr. A.Maha Lakshmi, Assistant Professor from the Department of Physics, St. Joseph College of Engineering. I am very happy to share the teach the transistor topics. Let us see how the transistor is formed. We know the transistor, the father of transistor is nothing, shortly is the father of our transistor. From the transistor only we have created all the IC chips, and then from that only we have in the VLSI design, computer, digital electronics, everything in the basic is nothing but the transistors. Okay. Next, how the word is formed, transistor. Transistor's meaning is transfer of resistors. So, so transistor is nothing but a semiconductor device that control the electric current by acting, which can act as a amplifier or a switch. It can be in olden days and all we used to point to the word as radio as a transistor. Yes, so which means it transfer the signals. It transfer the resistance, transfer the signal is nothing but we call the radio as a transistor. Yes, so transistor, the meaning of transistor is transfer of resistance. Yes, see, we can see the two word, the transfer of resistance. What is the meaning of transfer of resistance? Means which is nothing but it transfer the from the low resistance to the high resistance. So it transfer from low resistance to high resistance. Okay, low resistance to high resistance. This is the meaning. This is the meaning of transistor. Okay, while applying the voltage, it transfer from low resistance to high resistance. Yes. Then we can see one by one how they are formed. It is also called as BJT. We know it is also called as BJT. What is the meaning of BJT? How it is differ from the diode? Let us see how it is differ from diode. How it is evolved from diode. Okay, so transistor is a we can say as a two diode joined back to back. Yes, we can say in that way how the transistor is formed. The two diodes are joined back to form a transistor. See, this is one PNP, this is one PNP diode, and another is the NPN diode. See, this N type and N type are merged together. This N type and this N type are merged together, and we can form one single N type. So this is nothing but the PNP transistor. This PN diode and this NP diode combined together. So these two N region are sandwiched or combined. They combine. So we are forming one N region. So this is P region, and both N region combined together. So we have this middle one N region, and the bottom again we have the P region. So in that way we can form, or otherwise we can form NPN transistor. How we can form NPN transistor? This is the N region, and the two P region combined together. See, this is a P2 P region. What I told, two diodes are joined back to back. So this P and P will combine to form a single P. We combine to form a single P. And next this is the N region. So we have the N region, P region and N region. So totally we have three regions. In the case of diode we have only two regions, but in the case of transistor we have the three regions. Okay, so here in this case of diode we have only uh, uh, two regions, P and N. Yes, P and N. So here we are connecting back to back. So in this way we can form two types. It is of two types. One is PNP transistor or another is a NPN transistor. We can see in both the way, correct? So it is called as a bipolar junction transistor. So what is the meaning of bipolar is either it can have positive or negative. It is called bipolar. Okay, so consists of two PN junction diode, consists of two PN junction formed by sandwiching either a P type. So in this case the P type is sandwiched here, or N type. See, in this case N type is sandwiched. So between a pair of opposite types, between two P types or an N type, between two n-type or p-type. So it is clear. I think now it is very clear. So how it is transfer from the diode to transistor. So why we want to transfer? Why we want to sandwich this one? So main thing is diode is the uncontrolled switch. So we cannot control the flow of current in this case of diode. But transistor is act as a controlled switch. That's the main thing. The output of the current can be controlled. So that only we are sandwiching this two n-type and forming a single n-type, or this two p-type by forming a single p-type. So diode is the uncontrolled switching device, but transistor is the controlled switching device. Yes, keep it in mind. Transistor is a controlled switching device. So what is the meaning of this bipolar? Bipolar means two charge carriers, electrons and holes, two bipolar junction. So we are sandwiching this two thing and we are forming a two junction. So what are the two junctions we have? See, this is junction 1. This is junction 1, P and N. This is junction 1 and this is junction 2. This is N and P is junction 2 in the case of PNP. Similarly, in the case of NPN, this portion is a junction 1, which is the between N and P and N is nothing but the junction 2. So we have two junction 1, junction 2. So it is bipolar junction transistor. It is also called as, simply we can call as BJT. Yes, is how. So the current conduction in the bipolar junction transistor is either by two types of charge carriers, electrons and holes. Either we can have the electrons in this case of diode, what we say, the current conduction in the forward bias is only by the majority charge carriers and the reverse bias is by the minority charge carriers, easily we can say. But here we have the both electrons and holes based upon the NPN and PNP configuration. So it is called bipolar junction transistor. So it is also called as BJT. Yes, it is referred as NPN transistor and PNP transistor. This is a symbol of this one. So in this case of NPN, this is a symbol, and for this is PNP, this is a symbol. So the main thing is what we want to observe, the main point what we want to observe is from this symbol. See, the center region is positive. In this N, in both the side, the center region is positive. Yes, the center region is positive. So it is represented by the outward arrow. So the arrow should be outside. The arrow should be outside. But in this case of PNP, see, the center region is negative. So the arrow is inside. The arrow is inside. That's the difference between the symbol. So in this case of PNP, the arrow is outside. In this case of in this case of NPN, the arrow is outside. In the case of PNP, the arrow is inside. So from that symbol only we want to identify it is N-type or P-type. So while drawing the circuit, we want to keep it in mind always. The staff will observe only the arrow. So from that arrow only we can differentiate whether it is a NPN or PNP. In the remaining everything, the symbols or everything is same. See, I once again repeat, NPN. The center portion is positive. So which means the arrow is outside. In this case of PNP, the center portion is negative, so the arrow is inside. So from the structure only easily we can find out, from the arrow we can easily find out it is NPN or PNP. Yes. Next. So consist of, what are the components of transistor? We already told two diodes are sandwiched back to back. So we have three terminals. What are the three terminals? So first one is a emitter. What are the three terminals we have? Emitter, base, collector. So in this case of diode, we're not having any such a name, emitter, base, collector and all. P region, N region, that's the thing we have. But here we have three regions. So based upon the three regions, we are terming as emitter, base, collector. So from the symbol, let us see from the symbol, if the arrow is outside, so this portion is emitter, base, collector. So in this case of PNP, the center portion is negative, so the arrow is inside. So emitter, base, collector. So from the symbol we have three terminals, emitter, base, collector, emitter, base, collector. Here also we have emitter, base, collector. So both having the same terminals, but by the arrow we can differentiate. In this case of PNP, the arrow is inside. In this case of NPN, the arrow is outside. Is it clear? Okay, and let's coming to the structure, how it is differ from each one. So first one is emitter. And the word itself, you can easily find out what is the meaning of emitter. Emitter means it is ejected out. The electrons or holes or the charge carriers are ejected out, is nothing but the emitter, which emits the charge carrier is called as emitter. See, it is the outer region of a transistor. See in this diagram, emitter is this portion. This portion is the emitter. This portion is the emitter. This portion is the emitter. Yes, this portion is emitter. So it is outer region of a transistor. It is used to transfer charge carrier. So in this case of NPN transistor, electron is transferred. But in this case of PNP, holes are transferred. Okay. So it is a source. It is a source to transfer the charge carriers. So it should be heavily doped. So the emitter should be always heavily doped, which means it consists of it has large number of charge carriers. It is clear, large number of charge carriers. But coming to this PNP, we have large number of holes. So we have more number of positive charge carriers here. More number of plus will be there. More number of plus will be there. Here in this case of positive charge carrier will be there. Clear? But coming to this NPN, more number of electrons will be there. More number of, it is heavily doped. The meaning is heavily doped. Yes. This second layer is nothing but base. Second layer is base. So it is a middle layer of the transistor. It is very small in length. See the size of this one. This when compared to this collector and the emitter, the size is very small. So it is a very small in size and it is lightly doped. So here we have in this case of PNP, the charge carriers are holes. Majority charge carriers are holes. So this N region is slightly doped, lightly doped. Okay, we have only few electrons. Okay, so what is the purpose of this base? What is the purpose of this base? Just it is used to transfer the charge carrier. Just the purpose of this one is used to transfer the charge carriers. Okay, so it transfer the holes. In this case of PNP, it transfer the holes towards a collector. It transfer the holes towards a collector. Similarly, in this case of NPN, here it is electron. So in this P base region, we have holes. Just it transfer the electron. It's a mediator. Simply we can say it acts as a mediator to transfer the electron from one emitter to collector. So the size is very small. Okay. Next, coming to the last one, the important one is collector. Yes, the last one is collector. So what is a collector? From the word itself, easily we can find out. Collector means it collects the charge carriers. Yes. So it is the outermost one. This is the outermost and this is a collector is also the outermost one. So it is doped with the emitter and base. It is connected with the emitter and base. And what is size? See the size. When compared to the size, it is larger than the emitter. So it collect all the charge carriers. So which means it collect more number of charge carriers. It collect all the charge carriers. So where the size is very large and provides more number of charge carriers. Okay. Here it is negative. So it collect more number of charge carriers. See, keep it in mind. Emitter is heavily doped. Collector is lightly doped. In this case of PNP, it is doped by holes. In this case of NPN, it is emitter and collector is doped by electrons. That's it. Okay. So coming to the size, collector is larger but lightly doped. Emitter is little bit smaller than collector but heavily doped. Yes. So the size and the doping will be differ. Let's keep it in mind. So both are outer region, but emitter is heavily doped. Okay, and collector is slightly doped. Collector is slightly doped. When compared to both the emitter and collector, the base is very small one, and it is very much slightly doped by the opposite charge. Clear? So this is in this case of NPN transistor, this is collector, and this is base, and this is emitter. Emitter is heavily doped. So emitter only emits all the charge carriers. It's a source. It is a source. So all the all the charge carriers has emitter has more number of charge carriers. Then only it can transfer the charge carrier. So emitter is highly doped and more electrons are present in this case of NPN. And collector is little bit, the area is very broad, but it is slightly doped. Is it clear? Okay. Then, so how it is worked? What is the working mechanism of NPN transistor in both the case means in the forward bias and reverse bias. Okay, in this case of normal diodes, we all know the forward bias has current will be more, but reverse bias current will be less, right? Similarly, how the NPN transistor will work in both the forward bias and reverse bias. Okay, so see, in this case of forward bias, before going to this biasing and all, let us have the we can divide it into two junctions. So what are the two junctions we can say? This is the NPN transistor. Yes, NPN transistor. See this picture. See this picture clearly. We can say here we have more number of electrons. What I told you, emitter heavily doped. Emitter is heavily doped. We already discussed. Emitter is heavily doped. Same negative. And sky, this is a collector. Collector is the lightly doped. From the figure, it is clearly visible. Okay. It is slightly doped, it is heavily doped. So, how they are formed? So, this is nothing but the junction 1 and junction 2. So, emitter is in junction 1, emitter and base. Emitter and base is junction 1, base and collector is junction 2. Base and junction is collector 2. Is it clear? Okay. This is junction 1 and this is junction 2. Okay. Emitter base. This is emitter and this is base. This is the junction between emitter and base, and base and collector is junction 2. Base and collector is junction 2. Okay. And the important point we want to always keep it in mind is junction 1 is in forward bias. See, junction 1 is in forward bias. Junction 2 is in reverse bias. The main working mechanism is very simple. First one, which consists of more number of electrons, more charge carriers. We already know what is meaning of transistor. Transistor is transfer of resistance. Yes, from low resistance to high resistance. Yes, why we are using like this? To act as a switching device on the amplifier. Yes, so low resistance to high resistance, which means the junction, emitter and the base. Emitter and base, we all know emitter is heavily doped. So emitter and base, in which this is called as a junction 1, it is the forward bias. Next one, base and the collector. Base and the collector is a junction 2, which is the reverse bias. Clear? We can go for the concept. The junction between collector layer and base layer is called as the collector base junction. That is nothing but the J2. CB junction. The junction between base layer and the emitter layer is called as base emitter junction, which is nothing but J1. So we can write this as a J1. J1 and this as the J2. Okay. So the two junction have the same potential barrier voltage of 0.6 or to 0.7 just as normal diode. Okay, that's the working mechanism same. So if you take this J1, what is J1? N-type, P-type. Same potential difference. Coming to J2, P-type, N-type. So again it is act as a diode. So J1 act as a diode and J2 is also act as a diode. So the potential barrier of this voltage is nothing but 0.6 to 0.7 checked as a normal diode. Okay. So now, so how we want to apply the voltage? That's very important one. See this diagram. See this diagram. Here we have more voltage than this one, right? See, the collector is connected to a high positive voltage with respect to base. So VCB is very high. So from the figure, we can see it is highly high voltage. High voltage. The voltage is very, very high. The voltage is very, very high. The voltage is very, very high. But coming to this one, the voltage is very low. We are applying both the side. We are giving the potential difference voltage. So in this case of this one collector, we want to collect all the outputs, right? So which has a high output voltage, high output voltage. This voltage is connected between which one? The collector and the base. So collector and the base. So it is a high positive voltage is applied. But coming to this one, emitter and base, it supply the energy. So it is normally doped. Normally, voltage positive voltage is applied. See, VCB is very high. VCB is very, very, very high. VCB is very high when compared to PBE. Okay, output or the output voltage should be more than the input voltage. Clear? See, uh, next, the base is connected to the low positive voltage with respect to emitter. See, this is a positive one. This is a positive one. It is connected towards the negative. Here it is positive. See, first one, what I told you, this it is the forward bias. Junction 1 is in the forward bias. Let us check how it is works. Forward bias means, see, it is negative. So negative is connected. Base is positive, it is connected to positive. So forward bias. So it is a forward bias. So negative to negative. The base is positive, positive to positive. And coming to this one, junction J2. It is reverse bias. Let us check the reverse bias. It is negative. Negative is connected to positive. And this positive. Base is connected to negative. So junction 1 is forward bias and junction 2 is reverse bias. So why we are taking this as a junction 1? From the emitter only all the electrons is flowing towards a collector. So always emitter base is a junction 1, J1, and the output is connected to the collector. So it is the last one. So it is a junction J2. J2 is in the reverse bias. Clear? So the base is connected to low positive voltage with respect to emitter. So if we compare both the voltage, applied voltage, in this applied voltage, the output should be collected in the collector. So it has a higher positive voltage than this one. Clear? The base is connected to low positive voltage with respect to emitter. So if we compare these two, this voltage is very small. So VB is low, VCB is high. Okay. When we increase the VBE points on voltage, the transistor is forward bias. So if we apply the voltage of 0.7, the current starts to flow as in the normal diode. Okay. So when the current starts to flow, what happened? The electron is flowing towards the base and the collector. If we apply the forward bias, negative, negative, positive, positive, we apply forward bias, the charge carrier electron is moving towards the next junction J2. So that the current flows from the current flows from emitter to base. Okay, let us see the reverse bias. In this case of reverse bias, what happened? in this case of forward bias, the current is flowing from the emitter current by applying the Kirchhoff's law, and the emitter current is transferred towards which one? Towards the base and the collector. So the current is transferred from the base and the collector. This is a Kirchhoff's law formula in forward bias. Okay, in forward bias. Okay, next coming to reverse bias. So reverse bias of NPN transistor, where the forward bias it act as a switch, as we are told. In reverse bias, current through it is practically zero, so it acts as an open switch. In this case of forward bias, it is a closed switch. Current is flowing towards the base and collector, but it acts as an open switch. Let us see the circuit diagram. See, reverse bias. So same thing, emitter and base. It is junction 1, and then base collector. This is junction 2. Correct? So this negative is connected to positive. This P type is connected to negative. So which means this is reverse bias. This is reverse bias. Correct? Negative to positive, positive to negative. So reverse bias in NPN transistor. Next, coming to this one. Negative to positive. This is positive to negative. So J2 is also in positive to negative, negative to positive. So in reverse bias. So both the junction are reverse bias as the batteries are connected in opposite direction as shown in the figure. So the VCB reverse bias junction, VB is also reverse bias junction. So the charge cannot flow in this circuit. So it's partially act as a zero. We all know in reverse bias the current conduction is due to minority charge carriers. So in this case of NPN, the current is only by the maximum flow of current is only by the electrons. So and one more thing we want to keep it in mind, always see this one again, this VCB. This VCB is highly positive, high voltage than the emitter. Clear? Okay, next coming to the PNP transistor. Now we have finished about the NPN transistor, and next we have go for the PNP transistor. Clear? See how we can differentiate. We already informed to you what is the difference between NPN and PNP. How we can find out by the structures from the symbol. See this symbol, this arrow is acting internally. It's inside. So if it is pointing inside, if it is pointing inside, it is nothing but the PNP. Okay, so this is the base. From this is the base. So in that base we have one more line. One line is emitter, another line is collector. We should not combine together. There should be some gap between them. So in this case, it is emitter and this is collector, right? So the arrow passing internally, it is nothing but PNP. PNP. Okay. Yes. So in the PNP transistor, the current flow from emitter to collector. The same thing. Always the current flow from the emitter to collector. See the structure. So now this act as a J1 and this act as a J2. Correct? So in this the main thing is holes. Here what do you want to keep it in mind? The main charge carries holes. So the holes are the main charge carrier. In this case of NPN, electrons are the main charge carrier. In this case of holes, in this case of PNP, holes are the majority charge carrier. Okay. So holes require the base voltage that is more negative than the emitter. So the base voltage, see this is a negative one, this is the negative, the base voltage is more negative than the emitter. Yeah, so if we compare these two, it is more negative than the, here it is, this side it is positive. This side it is positive. Let us see first biasing, let us see forward biasing and reverse biasing. See, this is positive, it goes to negative. First see the junction 1. Junction 1 is always what we told, it is forward bias. So positive to positive, negative to negative. So it is forward bias. See, coming to this one, this is positive, negative, negative, positive. So it is reverse bias. We already discussed junction 1 is forward bias, junction 2 is reverse bias. Okay. So emitter base is connected to forward bias. So emitter base is connected to forward bias. So the positive terminal of the voltage source VB is connected to the base terminal of negative. Yes, right. So V C B C B. So the positive is connected to the base negative. Base, since it is in a reverse bias, and negative terminal of the collector P is connected to negative. So which means it is in a reverse bias. Yes. So in this case of both the things are in the reverse bias, the current will not flow in that circuit. Okay. So based upon the NPN transistor and PNP transistor, we can classify the transistor into 3 types. Okay, this is nothing but the common base, common emitter and common collector configuration. So how we are keeping? So the normal symbol what we are saying is the center is the base and we have the emitter and collector. Where we have arrow, based upon this arrow, we are saying as this as a emitter and this as a collector and this is the base. So we can change this 3 by 3 position. We can 3 position based upon the 3 position we can call as a common base, common emitter and common collector. Okay. So what is the meaning of common? Which one act as a center? So from this structure, see, let us see, the top is the collector and the bottom is the emitter. In between these two, the base is existing as a common one. So this is a common base. So let us see these 3 structures. See, in this structure, this base, it is emitter, collector and base. Okay, the base is existing between both the input and the output. So the base is acting as a mediator. So electrons in this electrons or holes, whatever it may be, the base act as a NPN or PNP. It may be anything. So in the base is act as a common one. So it is called as a common base. So in this configuration, so the same thing, always keep it in mind, J1 is in the forward bias and J2 is in the reverse bias. The same working mechanism is same. So how we are changing that 3 thing, based upon that one we can classify into common base, common emitter and common collector. Okay, see, this is the base. The input is in between the emitter and base. The input is between the emitter and base. So it acts as a forward bias. But coming to this output, the collector and base, it is act as a reverse bias. It act as output. So the collector and base is in the reverse bias. So in between these two, the base is present. So it is called as the common base. Next, coming to this one, common emitter. So now the input is input is base, output is collector. Here the input is emitter, output is collector. In this case of common emitter, the emitter is acting between both the input and output. So the base is the input and collector, as usual in this both the case, the collector is the output. So in the common emitter and common base, the collector is the output, the input only change. Okay, next the last one, special one, common collector. So the collector which act as a mediator between the input and the output. So the base is act as the input and emitter is act as the output. Let us see the working mechanism of each and everything. So what is the term of this common? So common is the between the input and the output. So here it is common base. So the base is the input between the it act as the middle common as the input and output. Next, coming to common emitter. So emitter is act as a common between input and output. So input is from the base and output is from the collector. In this case of common base, emitter act as an input and collector act as a output. The last one is common collector. Here the collector is act as a common one. The input is the base and the emitter is the output. Okay. See how the biasing in the case of NPN and PNP, which is a forward bias and which is a reverse bias. Let us see one by one. So the name implies that the base terminal, it is we are seeing for the common base. The base terminal is taken as a common between the input and output. So the base is the common. So automatically we can know this emitter. Emitter is input. Emitter is input. So collector is output. Collector is output. So this is the input. This is the input. Okay. So the common base, we have two types of transistor, NPN, PNP. Let us see both the things, NPN and PNP. So from the arrow we can say the arrow is pointing outside. So it is NPN. Here the arrow is pointing inside. So it is PNP. Clear? So we already know this. If we are saying this is a symbol, if we go for the structure, emitter, base, collector. Emitter, base, collector. So this one act as a junction 1, this act as a junction 2. What we discussed in the last slides, junction 1 is in the forward bias. So emitter and base is in the forward bias. Let us check this one. So it is the NPN transistor. So it is negative, it is positive, and it is negative. So this is a junction 1. It is in the forward bias. So negative is connected to negative. This positive is connected to positive. So it is in the forward bias. Correct. Next, junction J2 is in reverse bias. So junction J1 is forward bias. Junction J2 is in reverse bias. Yes. So in this case of junction J2, reverse bias. See, let us check that one. Negative. Negative is connected to positive. This positive base is connected to negative. So reverse bias. Obviously, it is correct for the NPN transistor. Next, coming to the PNP. Let us check the PNP. The same thing. Here it is P. It is N. It is P. PNP transistor. So this side, it is the forward bias. It is a forward bias. So positive is connected to positive. Negative is connected to negative. So it is the forward bias. Okay, right. Next, this is the output. Output is the reverse bias. So positive is connected to negative. Negative is connected to positive. So it is the reverse bias. So structure is correct. Clear? So this is the basic working mechanism for the common base. So always junction J1 is in the forward bias. That is input. Input is act as a junction 1, J1. Output is act as a junction J2. It is in the reverse bias. Clear? So the emitter voltage is applied. It acts as a forward bias. The electron from the negative terminal repel the emitter electron and current flows through the emitter base to the collector to contribute the collector current. So if you apply this, let us go for the working mechanism. This is negative. So the current is passing towards this one. So here the base has a higher potential. So the current will transfer toward from the base. From the base, it transfer from the base. Okay, transfer from the base. Transfer towards the base. Then the current is always what we had written as electrons Negative term will repel the emitter electron. So this is the negative, it repels. So automatically the current will flows towards the collector. Clear? Okay. The collector voltage CB is kept constant. See, in this case, to measure the output voltage is kept constant. So the input current is the emitter current and the output is the collector current. Since the base is very lightly doped and the size is very small, maximum the input current is transferred from the towards the collector current. So it is IE, input is the IE and output is the IC. Okay. In this case of this one, P and P, the same thing. The current is transferred from the emitter towards the, here it is the positive potential. Here it is the positive potential. So the current will transfer from here, this in this way. Here this in this case of VEB, base is in the positive potential. So the current is transferred in this direction. But here in this case of PNP, the emitter is in the positive potential. So current will transfer from in this side, in this direction. So IE is transferred towards the IB plus IC. But here IB is transferred towards the IE IC. Okay. Let us go for the common emitter. So in the case of common emitter, the emitter is in the middle. This is the input. This is the input. This is the input. And this is the output. This portion is the output. This portion is the output. You get the same thing. NPN transistor. So this is the negative. This is positive. Base is the positive and this is collector. Clear? Okay. Let us have this one. This is the positive. Same. Junction 1 is in the forward bias. Junction 2 is in the reverse bias. So in this case of common emitter, NP, sorry, it should be written as N negative, NPN. Yes, NPN transistor, emitter, base, collector. So the configuration which the emitter is connected towards between the collector and the base is known as the common emitter configuration. So the input circuit is connected between the emitter and base. The output is connected between the collector and emitter. Okay, so emitter is acting between both the input and output. So it is called as the common emitter. Okay, so we have given the connection. So here it is IB. It is nothing but the input current and IC is nothing but the output current. Okay. Similarly for this one, PNP transistor, which is this is the P positive and this is N and this is PNP transistor. Okay. Next, the last configuration is common collector configuration. Here, the input is applied between the base and the collector. So this is the emitter. This is the emitter. And this is the base. This is the collector. Right? This is the structure. And coming to NPN transistor, which is the emitter, this is the N. And this is P. This is P. Collector is negative. Clear? So, and the base and the collector, the input is applied between the base and the collector. The input is applied between the base and the collector, and the output is taken from the emitter and collector, emitter and collector, emitter and collector. So the collector is acting as in between both the input and output. So it is called as the common collector circuit. Okay. So when it is quite different from the common base and common emitter. See, the difference is fact that this the input voltage V CB is large. VCB is large, determine the value of the collector to emitter voltage. See, in this case, the input is low, output is high. The input is low, output is high. Clear? The common collector configuration, high input configuration and low output impedance. So low output impedance. So because of this one, the gain is very voltage gain is very small, but the current gain is very high. So therefore, the power gain is in the range of medium. So the high impedance source is producing in this one. So most of the time we're not commonly using this common collector. In most of the case we are using the common base and the common emitter. Okay. Next coming to the common base. What is a common base? See, let us see. The emitter voltage is applied. We already seen about the common base, common emitter, common collection, everything we have seen. To find how much voltage is passed and how to find how much current is we are passing to this one. So in this structure, we already shown some of these structures. No, yeah, along with the structures, we are connecting the ammeter and voltmeter and resistance to find the how much our current price, how much we given as an input current and how much input voltage and how much output current and how much output voltage we are giving the structure. So let us see the structure first of all. See, this is the common base. So this is a common base and the arrow is acting internally. Okay, the arrow is acting internally. Okay, which means it is the PNP transistor. Okay, oh sorry, NPN transistor. Okay, so first one. So from this, the emitter voltage is applied. It is the forward bias. So emitter voltage is applied. So this is the connection between emitter and base. It is positive. So this positive is connected towards the positive. This negative is connected towards the negative. So forward bias. The emitter voltage is applied. It is the forward bias. So electron from the terminal repels the emitter electron and the current flows through the emitter and base to the collector to contribute the collector current. So it is positive, it is so this is positive negative. So in this voltage is also in the parallel to this one, it is positive negative. This positive current is flowing, so it is positive and this is negative. Next is the this is the PNP transistor. So P N P. So we already discussed junction J1 is the forward bias. So this is positive is connected to positive. So junction J1 is forward bias. So it is positive and then it is negative. It is connected to negative. So now we can clearly see and the full structure. So first one, to find how much input current is passed, we want to find how much the input current is passed. So this output is kept as a constant. So first one, the collector voltage VCB is kept constant. So first we want to find the input current. So to find the input current, the output voltage is kept as a constant. So in this CB configuration, the input current is the emitter current. So the current is flowing from here to here, it is input current. So input current I is the input current. And where we getting the output? Since it's a common base, the base is acting middle in between, it will act as a common. So the output is taken as the collector. So IC is the collector. So IE is the input and IC is the output. Okay. So input is IE, input is IE with voltages V, it is between the emitter base. So emitter base input. So output is, where are we taking the output? Output is collector. So it is IC. And the output voltage is between the base and the collector. So collector and the base. This is a key point. Okay. See input characteristics. Let us see the input characteristics. First one, the curve is plotted between the IE and the uh, input voltage, base emitter voltage. So how much current we are giving. What we told already, the output voltage should be constant. So output voltage is V, collector base voltage is kept constant. Okay. So we are giving the forward bias. In the case of forward bias, the charge carriers will move from the emitter towards the collector. So okay, for the specific value of VCB, the curve is act as a normal diode, as a normal function of forward bias. So the PN emitter junction is in forward bias, junction 1 is in forward bias. When the value of the voltage base current increases, the value of emitter current increase slightly. So the junction behave as a better diode. So the emitter collector current is independent of the collector base current. So we already discussed, the emitter collector current is independent of the output voltage. So since the energy is transferred, the current is transferred from the emitter and base is common. So in the output is, there is no purpose of our output. So output is act as a constant one. So V output voltage is kept as constant. Clear? The output, it is independent of the collector voltage. We want to, if we increase the voltage, so based upon the increased voltage we get the output current. Okay, so the input resistance, what's the formula for the input resistance? The input resistance is a ratio of change in the input voltage. What is input voltage? Input voltage is emitter base voltage. The change in the emitter current IE, the input current is emitter current IE with the constant output voltage. So constant output voltage is collector base voltage. So therefore the formula is Ri is equal to the input voltage is V in between base emitter, so BE, and the input current is given from IE since the base is common. So VBE by IE with the output voltage constant. So it is VCB. So the value of collector base voltage increases with the increasing in the collector base current. So the value of input resistance is very low. So what is the meaning of resistance? In transistor we all discussed, low resistance to high resistance. So the input resistance is very low. It is in the value of few ohms to 10 ohms. Is it clear? So we have given the connection in the middle to find the voltage and to find the amount of current, and we are connecting the voltage in the voltage and ammeter in the towards the input. Okay, to find the current IE and IB, etc. Voltage across. Next one, output characteristics. So what is output characteristics? It is act as the reverse bias. Yes. So the output is taken in the between the base and the collector. Yes. So therefore, uh, the curve is plotted between the collector current and the collector base voltage. Output current is taken from the collector. So collector current, and with respect to the voltage, which is nothing but the collector base voltage, VCB. And then with respect to which one, already the current is passed from the emitter. So the emitter current is transferred towards a transistor and to from the center towards a collector. So always the emitter, the input current is constant. Therefore input current is nothing but the emitter current. Emitter current is constant. So the active region of the collector base junction is reverse bias. We already discussed J1 is forward bias, J2 is reverse bias. Here the J2 is nothing but the collector base. So in this case of common base, the collector base is then the output. So it is a reverse bias. So the collector current IC is almost equal towards the emitter current. Since the base is very small and it is acting as middle between the emitter and the collector, and moreover the applied voltage is very high, so the maximum current is transferred towards the collector. So the curve of the active region is almost flat. See, after reaching this constant cutoff region, the current is constant. Clear? So the curve in the active region is almost flat. It's almost flat. So the large charge in VCB produce only a tiny change in IC. The circuit has very high output resistance. Okay, the transistor meaning is transfer of resistance from the low input to high, so low resistance to high resistance. Yes. So here the VCB is positive. The collector base junction is forward bias. The collector current decreases steadily. See, in this case of saturation state, in which the collector current does not depends upon the emitter current. Irrespective of emitter current, the current will be in the flat region. Okay, when the emitter current is 0, the collector current is not 0, which means the current which is flow with the act as a, which is in the leakage current. The current which flows in the circuit is in the reverse leakage current. So it is very small. In the case of 0.1 to 0.1 microampere, the current is very slow. But in the case of germanium, it is in the range of 2 to 5 micro ampere. Clear? So let us coming for the output resistance. What is the formula for output resistance? Output resistance is nothing but the voltage by current. The formula for resistance is voltage by current. What the output voltage? Voltage is collector base voltage. And what is the current? We are collecting the current from the collector. So it is the IC. So therefore VCB by IC with the constant input current. So constant input current is nothing but IE. Therefore the output characteristics is the change in collector current is very little with the change in V collector base, voltage across collector base. Therefore, with the change in collector base voltage, the output resistance is very high in the order of several kilometers. See, when the IE is 50 milliampere, the current is IC current is milliampere, is 50. If we reduce to 40 milliampere, it is 40. So the curve is very flat. And if we decrease the, if not having any input current also, we have very small amount of leakage current. Clear? Last is nothing but the current amplification. So how much the current is amplified, whether it is increase or decrease, let us check. The ratio, what is the formula for this one? The ratio of change in collector current IC to change in the emitter current IE with the output voltage constant. Collector voltage VCB is kept constant. So almost what we told is IC and IB are same. Here it is a common base. So all the current flowing from the emitter is flowing towards the collector. So almost IC and IB are equal. So what is the Kirchhoff's law? Kirchhoff's law states IE is equal to IB plus IC. IB plus IC. In this case, IB is 0, almost equal to 0. IB is approximately equal to 0. Therefore, what we can write? IE is equal to IC. Both the input current and the output current are equal. Okay, therefore, the value of current amplification factor is less than unity. It's around 0.99, like that we can get it. So there is no much difference in this case of common base. So there is no much gain. The current amplification alpha. The symbol for this one is alpha. In the case of common base, the symbol for is alpha. So the collector current. What is the collector current? Collector current is we already have the leakage current plus the emitter current is transfer. So we can say the base current is because of the combination of electrons and holes in the base region. The whole emitter current will not flow towards the collector. There's a small leakage that due to the minority charge carrier that is represented as I leakage. And the large percentage of emitter current reaches the collector current, which is nothing but alpha. So by this formula we are saying, okay, this is nothing but IC, which is equal to alpha into IE. Therefore, leakage current is due to the minority charge carriers and current produced collector current, which is equal to alpha IE plus leakage current. So with this we can conclude our concept. I think I have clearly explained everything. So thank you for your patience to attend this session. Thank you very much. Thank you.